Hello everyone. Hi everyone, how you all are doing? Hi everyone, how you all are doing? Yes, good afternoon Amo. How are you? Yes, good afternoon Guru. Good afternoon Viraj. Yes, hi Rahul. Hi, hello Piyush. How you all are doing? Alright. What is your doubt, Atharv? Can you please tell me your doubt? What is your doubt, Atharv? Can you please tell me? Can you tell me your doubt? What was your question which I did not answer? Okay, so I welcome every one of you to this class in which we are going to talk about motion. Okay, so what was taught in the previous class? Can you please tell me? Okay, Atharv, you want to know 5 rules of significant figure, right? You want to know the significant figure rules, right? Am I correct? No, we will not have acceleration in this chapter. We will learn acceleration in the next chapter. Okay, Atharv. Were you there in the second class which I have taken? That was totally based on significant figure. Were you present in the class, Atharv? You were present in the class or not when I taught this? So everyone else did you understand the concept of significant figure? Every one of you kindly respond in chat box. Right? Okay, so everyone, rest of the people understood other than Om and Atharv. Arvind was absent. Okay, so what I recommend you to do, if you have recordings, go through my recordings once again and try to listen carefully. Okay, because the rest of the people have understood that lecture. Okay. The trailing zero in the number with the decimal are significant. Yes. Yes. We count it as significant figure. You are correct. Okay. Okay. If you cannot find the recording, I would recommend to contact the customer support team and ask them to provide the recording. Okay. Alright. Go through my recordings. Okay. And learn the concepts and then go through the doubt session. Okay, you had the one doubt session, right? Okay, this is your first class. So basically in this class I am going to start a new chapter, right? This is motion. Okay, this is the basic chapter of mechanics. Alright, so those people who are attending this class first time, so you are going to be on safe side because this is the first class of this chapter. Okay, in the last class we discussed about the doubts of the chapter, that is units and measurement, right? We discussed about units and measurement, right? See, Chandralekha, for NCERT purpose, it is very important. Okay, in your higher classes you will learn. But if you talk about I3G and AIPMT, that chapter is not that important if you compare from other chapters. Okay, you will get only 1 or 2 or 3 questions hardly. Alright, but okay. So if you are not present in any class, you will get the recordings, go through the recordings 2 times, 3 times, then you will get to understand the concept thoroughly. Alright? Okay? I recommend every one of you to go through the recordings if you have any doubt. Okay, because I cannot cover the chapter which I have covered in the previous class in this lecture. Alright? Yeah, good morning Harsh. Okay. So let's start the chapter motion. So what is motion? Do you all know what is motion? What is your doubt, Viraj? Can you tell me? Measurement important, not important. Measurement is important, but it is not that important, okay? It is not that important. Khas, can you ask me what is the question? You want to ask me any question? So if you are aiming for IIT, it is important, but it is not that important if you talk about other chapters. Okay, you will only get 1 or 2 questions. That too very easy questions. All right. Okay. Yes, motion. So motion, change in position of an object, right? Okay. All right. So let's talk about this lecture right now. Okay. Let's talk about this lecture which I'm going to cover today. So basically we are going to talk about motion and rest, and we are going to talk about the quantities that are required for motion, to define a motion. Okay. All right. So motion you have defined. Yes, you all are correct. Motion is basically changing position of the object with respect to the time. Okay. All right. So let's go ahead and let's talk about rest. The position that is rest. So what is rest? What is rest? Not moving. All right. So let's begin the chapter. So I'm going to disable the chat for every one of you. You can listen to my lecture properly. Okay. So kindly listen to my lecture properly. I will be asking some questions to every one of you. So you would have to answer that question, and kindly do not write anything irrelevant in the chat box. I will switch on the chat box only for some times. So use that chat box very efficiently, because you will get only very small time to reply to my questions. Okay. Use the chat box very efficiently. Don't write anything irrelevant. And I will not be able to answer each and every question. I will try to answer common questions, but I will not be able to take personal questions. If we get time, we'll talk in the end of the class about personal questions. If we get time, then only. Okay. Otherwise, you can post the questions on our ask and answer forum where our expert team can answer your questions in much more detail. Okay. So let's talk about, and those who were not present in the last class and before classes, what I recommend you to do is kindly go through the recordings. Okay, go through the recordings of doubt session, go through the recordings of my lecture which I have taken, or the previous class. So go through all those recordings. So you will get to know the concepts very easily. Alright. So we're talking about motion in this lecture. Let's start with object at rest. So object at rest basically defined as the object which does not changes its position with respect to surrounding in certain interval of time. Those objects are said to be at rest. I repeat once again, definition of object at rest is when the object do not change its position with respect to its surrounding in certain interval of time. Okay, that is said to be at rest. Okay, so you can see that there is a house and it is fixed with respect to this ground, with respect to this grass and other things. Okay, so this house is at rest. Similarly, you can see this electric pole. This electric pole is at rest with respect to this wire, with respect to this tree, with respect to this ground, with respect to this house. It is at rest. It is not changing its position. Alright, so this pole is at rest. Okay, and similar case will be for this tree. This tree is at rest because its position, it is not changing with respect to this ground. Okay, or some other things which are present there. So it is not changing. So when the position of the object does not changes with respect to the surrounding in a particular time interval, then it is known as rest. That state is known as rest. So object is said to be at rest when its position does not change with respect to time. Alright, that is the definition of rest. If the object is not at rest, then it is in motion. So what is motion? When the object changes its position with respect to its surrounding in a particular time interval, that state of motion is known as motion. That is known as motion. So definition of motion is basically when the object changes their position with respect to the surrounding in certain interval of time, then the object is said to be in motion. Now some examples of motion you can see here. This horse is running. This horse you can see is running with respect to this boundary wall, with respect to this tree, with respect to ground. It is moving forward. Okay, so this horse and this woman who is sitting on the horse, she is also moving with respect to the other things which is present there. Okay, so this woman is also in state of motion. Similarly, this cheetah you can see is running very fast in forward direction. And how you can say it is in motion? Its position is changing with respect to this grass, with respect to ground, with respect to other things. Okay. So its position is changing. That is why it is said to be in motion. So this theta is also in state of motion. Now this athlete, you can see here there is an athlete. There is an athlete who is running. So his position with respect to these trees, with respect to this ground, this road, and this mountain, you can see here, his position is changing. His position is changing with respect to this objects that surrounds him. So its position is changing. That is why he is in state of motion. Then similarly, this car is moving with respect to this ground. This ground is at rest. It is moving with respect to the ground. It is moving with respect to the boundary, with respect to this open area. So this car is moving with respect to the object surrounding it. So this car is in a state of motion. So an object is said to be in its state of motion. The position of the object changes with respect to the other objects present nearby it and in a certain time interval. Okay, this was about rest and motion. This was all about rest and motion. Is this clear to every one of you? Rest and motion, it is very basic thing. This is a very basic definition. Okay, all right. Okay, so this is a very basic definition. Yes, yes, Aviral, very nice. You can see here there is a woman and there is a horse. So this woman, she is moving with respect to the objects surrounding it because her position is changing with respect to those objects. Now, position of this woman is not changing with respect to this horse. So with respect to this horse, she is at rest. That we will define further. Why is it happening so? Okay. So she is at rest with respect to the horse. All right. Okay. So let's move ahead then. So about the rest and motion. Okay. Now, what is definition of motion? So I have already defined what is motion. I have already defined what is motion. So motion basically is the body is said to be in state of motion when its position changes continuously with respect to the stationary reference point. So I'm talking about the body, any body, if it changes its position with respect to stationary reference point. This is a very important term. This is a very important term. With respect to a stationary reference point, when the body changes its position with respect to the stationary reference point, then that body is said to be in state of motion. I repeat it once again. When the body is changing its position with respect to a stationary reference point, then that body is known as to be in motion. Now let's talk about cars. So this is car number A, this is car number B. This is car number A, this is car number D. You can see that one of the car is moving. Among A or B, one of the car is moving. Okay. So can you all please ask me, can you all answer me in the poll that which car is moving, A or B? Kindly respond in the poll which car is moving, car A or car B? Can you respond in the poll which car is moving? So I'm going to, first of all, I'm going to minimize it. You can see that this is car A, this is car B. So who is moving? Which one is moving? Can you tell me? A or B? So I think this is a wrong poll. Okay, so yeah. Which one is moving among A or B? Alright, so I'm going to show the results to every one of you. You can see that most of you have answered that option B is correct, and you all are right that car B is moving. And how you can say that? You can say that car B is moving because you can see that with respect to this building, which is stationary, the building is at rest, okay, it is stationary. With respect to this building, its position is changing. It is at this position. Now it is at this position. Initially it was here. So its position is changing. Okay. So position with respect to stationary object changes, then that object is said to be in state of motion. Okay, then it is said to be state of motion. Okay, so that is why car B is in state of motion. Alright, is it clear to every one of you why car B is in state of motion? Alright, okay. So, Harsh, you are saying that Earth is moving, right? You are saying that Earth is moving. Yes, Earth is moving because it is moving with respect to Sun. Okay. But if you talk about object with respect to Earth, they are not moving. This building is not moving with respect to Earth. Okay. So this is at rest. Alright. So generally we take Earth as reference, ground as reference. Okay. Alright. We're not talking about solar system. We're talking on the Earth only. With respect to Earth, many objects are at rest. This tree is at rest with respect to Earth. This car is at rest. Okay, this guy is at rest with respect to Earth. But only thing is that car is moving. Car B is moving. Alright. That is why car B is in state of motion. So let's stop. Why does this happen? Okay, why does this happen? Why the car and object, they are in state of motion and rest. So basically what happens that rest and motion, they are basically relative terms. Rest and motion, they are relative to each other. Okay. Why so? Because for a person, so let's take this example where there is a train going on, it is moving, train is moving. Now the person sitting inside the train, the outside world seems to be moving. Okay. For a person sitting inside a train, the outside world seems to be moving. Alright. And the person outside the train seems to be moving. Okay. So actually the motion is relative. Okay. And it depends on the place from where you are observing the motion. Okay. So let's take this example. There is a man outside the train. There is a man outside the train. Okay. This man, according to this man, let's say this is A, this is B. According to man A, this train is at rest. According to man A, if I'm talking, train is at rest, and man B is moving. You will see that train is just at rest with respect to him, but that man B is moving backward. With respect to man B, what he will see, that train is moving and man A is also moving. Okay. With respect to B, the train appears to be in motion. With respect to A, the train appears to be at rest. Why so? Because it depends on the point from where you are observing the object. The object to be observed is train here. If you are observing the train from inside the train, it will appear to be at rest. Okay. But if you observe the train from outside the train, you will see that it is moving. Okay. So both of them are relative terms. Alright. Sometimes the object will be at rest or at motion. It depends on the point of observation from where you are observing it. Okay. That is why we say that rest and motion are relative terms. Rest and motion are relative terms. They are related to each other. Okay. Let's then move ahead. Ayush, I can see you drawing freehand on the slides. Okay. Kindly do not draw any freehand on the slides. Alright. I'm not going to repeat it once again. Kindly do not draw any freehand on the slide. If you are going to draw freehands, I'm not going to open the chat for you, and I'm not going to ask you whether it is easy, whether you understood or not. Alright, so this slide is clear to every one of you? Why they are related terms? Alright, so it's clear to most of you. Okay, it's clear to most of the people. Yes, Chinmay, with respect to observer you can say. Okay, but generally we talk about Earth only, so we consider the stationary object. But with respect to observer we can say, you are right. Okay. Alright. So let's then move ahead. Let's then move ahead and let's talk further of rest and motion. So rest, you all might have learned that there is nothing to discuss about rest because there is no quantities that defines rest. Okay, that is used in rest. But in motion, there are various types of motion. If the body is at rest, there is no type of rest because it will be at rest, so it will not move. Its position will not change. It will remain at that position only for a longer time. It will continue to be at that position only. So there is nothing to discuss about rest. Motion now. Let's discuss about motion. So basically, what is motion? Motion is basically changing position. So how we define types of motion? The types of motion we generally define by like if the object is changing its position. So in what way it is changing its position? It is moving in straight line or in circular way, or it is moving backward and forward again and again and continuously moving back and forward. So it depends. Okay, so we have defined the motion in that way only. Types of motion. So basically types of motion is defined in three types. Okay, first is translatory motion. Okay, first is translatory motion. Second is rotatory motion. And third is oscillatory motion. These are the three types of motion. First is translatory, second is rotatory, third is oscillatory motion. Alright, these are the three types of motion that are very important and that we are going to discuss in this lecture. So starting with translatory motion. Okay, so translatory motion we'll learn about. Translatory motion is the motion in which all the points of a body move uniformly in a parallel straight line. It is the motion in which all the points of a moving body move uniformly in a parallel straight line. Okay, this is translatory motion. So translatory motion, you can see the example. Example is the vehicle moving in a traffic lane. The vehicle moving in a traffic lane, they move in a straight line. Okay, they move in a straight line, and each and every point moves parallel to each other in a straight line. Okay, so translatory motion basically is a straight line motion. Translatory motion is basically straight line motion. Okay, so in this motion, all points of a moving body moves uniformly in a parallel straight line. Okay, translatory motion is clear to every one of you? Alright, it is basically a straight line. If the body is moving in a straight line, then it is translatory motion. Okay, the body is moving in a straight line. So Guru, if you see overall, light moves in a straight line. Okay, if you don't get into details of the wave of electromagnetic wave of light, it moves in a straight line only. We say that light always move in a straight line. Okay. So Ayush, if you are clicking on the smiley or screen, kindly don't click. Okay, just listen to the recording. Just listen to the lecture. I am giving the lecture here. Listen to my lecture. Just click on the chat box when I am asking for you to respond. There is no need to click from your side. Okay. Kindly don't draw anything on the whiteboard. It disturbs the class a lot and it disturbs my flow. I'll not be able to teach properly, so you will not be able to gain the knowledge. Okay. Ultimately, it's your loss. Whatever fault happened in this class, it will be only your loss. Okay. Don't do any such thing, so it disturbs the class. Alright. So translatory motion is basically, you can, in simple language, you can say that it is a straight line motion. It is straight line motion in which every point of the body moves parallelly in a straight line. Every point of a body. So in this example, you can see This is a traffic lane. This is a traffic lane. Now in traffic lane, basically all the vehicles they move in a straight line. Okay. In India, most of the people does not follow lane system, right? In traffic lane, none of the people I've seen they follow lane system, especially Mumbai, Delhi, and other places I've seen. None of the people them follow a lane system. No, none of them move in a straight line. Okay, so basically, when the vehicle moves in a one lane, in one line, in a straight line, then it is said to be a translatory motion. Okay, now is it clear to every one of you? Now it's clear to every one of you? All right. Okay. Let's move ahead. Let's talk about motion. What is rotatory motion? So it is the motion in which all the points of the body move simultaneously along a concentric circle whose center lies at the axis of rotation. Okay. The motion, this is the example of rotatory motion. The motion in which all the points of a body move simultaneously along concentric circles. So you can see that these, let's say these are some points. Okay, this is one point, let's say this is one point. This will move across this circle, right? Now if I draw another point, and let's take another point, this point, it's moving this circle. So all the points they move in a concentric circle. What is concentric circle? Which have only one center. So there is only one center. Every circle will be from this center only. Alright. So this is the example of rotatory motion. This is basically a merry-go-wheel or giant wheel. Okay. Merry-go-wheel or giant. Alright. So basically it is example of rotatory motion in which all the body moves, all the point moves in a circle. Okay, in a concentric circle. Alright. This is rotatory motion. Let's move ahead of rotatory motion then. So is it clear to everyone of you? Rotatory motion, it is basically movement in a circle. Okay. Alright. Okay. This was about rotatory motion. Let's then move ahead. Let's talk about oscillatory. Let's talk about oscillatory motion. So oscillatory motion, basically when the object moves to and fro a fixed point, it is known as oscillatory motion. Okay. So you asked me what is linear and translatory motion, right? Difference between rectilinear and translatory motion. Alright. So I'll reply to this question. Just wait for 2 minutes. So let me finish this slide first of all. Let me finish this slide, I'll reply to your question. So a motion in which a body moves to and fro about a fixed point. So you can see this is a swing, right? This is a swing. Okay. And there is a fixed point. Let's say this is, I've drawn a swing here. Okay, and this is a fixed rod, a fixed point. A fixed line across which it is moving forward then backward. What we do, we take it forward, then it moves backward. Then again it moves forward, then backward, then forward, then backward, then forward, then backward. So this is basically to and fro, forward, backward, forward, backward, forward, backward. This is basically to and fro motion. Okay, it is basically to and fro motion. Alright, so it moves first of all forward, then backward, and it continues to move in that motion only. That is called oscillatory motion. Rectilinear motion, basically they are moving in a straight line, alright, and in rotating motion it moves in a circular path, alright, and in oscillatory motion they move to and fro. Okay, alright. So you asked me the question that what is difference between linear and translatory motion, right? Linear and translatory motion. So linear motion is the motion along straight line. Okay, all right, and translation motion is the movement that changes position of the object. It's the movement that changes position of the object. Okay, that is right. Translatory motion. It only moves. Okay, it can move in any way. All right. That is rectilinear motion. Translate motion. In rectilinear motion, it moves in a straight line. All right. It moves in a straight line. But in rectilinear motion, in translatory motion, all the points move uniformly in the same line. Okay, in the same direction. Okay, so it can be like, let's say it is moving this, then this direction, then this direction. So all the point moves in the same direction. Okay, if it is moving in this direction, it in this direction, then it changes. Okay, but in rectilinear motion, it moves in a straight line. All right, it moves in a straight line. Okay, so let's move ahead. So is it clear to every one of you? Oscillatory motion. Is it clear to every one of you? All right. Okay. So this was about types of motion. This was about types of motion. So Guru, you asked me, can we say less than half the circle motion is oscillatory? Yes, we can say that. I mean, if it is to and fro, it will move forward and move backward, then we can say. Okay, if it move forward and move backward, we can say that. All right, Guru. So these are the examples. I mean, these are the some definition example of types of motion. So straight line motion, that is linear. Then there is rotatory motion, and then there is oscillatory motion. So we have discussed rectilinear, that is straight line motion. We have discussed circular motion, and we have discussed to and fro motion. Okay, we discussed all these three motions. It is rectilinear, rotatory, and oscillatory motion. These three motions. So example is traffic lane, merry-go-round or merry-go-wheel, and swing, or pendulum. Now let's move ahead. Let's talk about periodic motion. So what is periodic motion? Periodic motion, basically the motion which repeats itself after every interval. Okay, oscillatory motion is a type of periodic motion. Okay, the motion that repeats itself after every. So one example is Earth and Sun. After every 365 days, Earth repeats its motion. Earth repeats its motion across the Sun. After 65 days, it will come back to its position once again. Then again it will come back after 65 days. So it is periodic motion. Okay. And similarly, you can say clock. The hands of the clock, this hour hand, I mean it again, it comes back to its position after 24 hours, or minute and come back after 60 minutes. Okay, so both of these hands will repeat their motion after every 24 hours or 60 minutes. Okay, that is why this is also said to be in periodic motion clock. Okay, so a motion that repeats itself after every time interval or equal time interval, that is known as periodic motion. The motion that repeats itself after equal time interval is known as periodic motion. This was about types of motion. Okay. Okay, is it clear to every one of you, types of motion? Okay. All right. So I think it's clear to every one of you, most of you. If it's not clear to any one of you, okay. So Suniket, what I told you, when the car moves in a straight line, okay, in traffic lane, what rule says, when you move in one lane, you are moving in a straight line. Okay, that lane is a straight line. Okay, when you move in a lane, you move in a straight line. But India, people does not follow lane system. Okay, when a car moves in one lane, then it moves in a straight line. Okay, so we can say that it is a rectilinear motion. All right. No, translatory motion is not a random motion. It is not a random motion. Okay. All right. So let's move on. Let's move on after periodic motion, and let's talk about important terms related to periodic motion. As I told you, in periodic motion, every particle or every object repeats its motion after a particular time interval. Okay. So there is one time period. Okay, if I'm talking about that particular time interval, that time interval is called time period or period. Okay, it is the interval of time after which motion repeats itself. So what I told you about periodic motion, in periodic motion the object repeats its motion after equal time interval, and that equal time interval is known as period. So let's say this is the graph. Okay, so this is the graph basically, in which this is one cycle. Okay, this is another cycle, this is third cycle, fourth cycle, and so on. Alright, so time taken for one cycle is equal to time period. Time taken to complete one cycle is equal to time period. Time taken to complete one cycle is called time period. So it is the interval of time after which motion is repeated. The time interval after which the motion is repeated, and its unit is second. Okay, this time period is called, this time is called time period. The time after which the motion repeats itself is called time period. So for Sun and Earth, time period was 365 days. Because after 365 days it comes back to its position and again it repeats its position. Similarly for our hand, because it is 12 hours, because after 12 hours it comes back to its position. Only difference is AM and PM, right? But motion it repeats. For minute hand, the time period is 60 minutes. Okay. Now frequency, number of repetition that occurs per unit time. Number of repetition that occurs per unit time. Okay. So first of all we discuss about time period. Let me rub it. Now what is frequency? So it is related to unit time. So let's define unit time first of all. Let's say this is 1 second, that is unit time. And let's say it has repeated 3 cycles in 1 second. So 3 is the frequency. 3 is the frequency. Or let's say it covers 1 cycle in 365 days, right? So how much cycle it covered in 1 day? So 1 day it covered 1 upon 365 cycle. Okay. So frequency basically is equal to 1 upon time period. Frequency is equal to upon time period. Okay, number of cycles per unit time. Alright, that is frequency. Now what is displacement? It is change in position. Displacement is change in position. So what is displacement basically? Let's say this is the position at which the object is at rest. Okay, this is the point. If I keep it at this point, it will not oscillate. If I take it away from this point, that is called equilibrium point, where every force is balanced and where it will be at rest. If I keep the pendulum at this position, it will be at rest. If I keep it to this height, it will start moving. Okay, it will start moving like this. But if I keep it here, if I keep it here, it will be at rest only. If I take it at this point, so this is a displacement. Between this point and this point is called displacement. Similarly, for this case, spring and block, when it is kept here, it is kept here. Okay, it is at rest. If I take it away from this position, let's say x0, then it will pull it back. It will start moving forward and backward. Okay, but this position is called the position at rest, and this is called displacement. Displacement, that is changing position. Okay, so is it clear to every one of you? Time, period, frequency and displacement. Alright, so it's clear to almost every one of you. Okay, it is not that easy term. No, pendulum does not stop in vacuum, because pendulum works on the principle of gravity, not on other thing. Okay, not on air or medium. It is simply based on the gravity. Alright. Okay, so let's then move ahead. Let's talk about pendulum only. Okay, let's talk about pendulum. So what is pendulum? It is an example of oscillatory motion. Okay, it is an example of oscillatory motion. So a simple pendulum consists of a mass that is suspended by a string. Okay, it is suspended by a piece of string. Now the mass is known as the bob of the pendulum. So this is the bob. Sorry, this is the bob. We call it bob. That is not the Bob the Builder. It is different. We call it bob. Okay. Now, and the length of the center point of the bob from the point of suspension is the length of the pendulum. So this length, this is center to this point where it is fixed. This length is called the length of pendulum. Okay, the center to this point where it is fixed. In this case, this is the length from center. Also in this case, this is the center. This is the center and this is the center. So this length is called length of the pendulum. Length of the pendulum. Alright. So this basically depends. This is the length of the pendulum. Alright. And this is the bob, that is the mass which is responsible for the to and fro motion. Now the pendulum is shown in the figure. Here point O is the mean position. So I told you this is the mean position, okay, where it is at rest. This is the mean position. If I move at this point, it is not the mean position. It will start moving forward and backward. But if I keep it at this point, it will be at rest. It is the mean position. Okay. If I displace it, it will start at oscillatory motion. Okay. So this is the mean position. So O is the mean position where all the forces are balanced. So there is gravity in downward direction, so it will not move. Okay. So this is the mean position. This is the mean position of the pendulum, where the motion will not take place if you keep it at this position. Now, if you lift the bob to point A, if you displace the bob to point A, so the bob begins to move to and fro when it is released from the extreme point A. Okay, if you take the bob at point A, if you release it, it will start to and fro motion, forward and backward motion. Alright, and that is called oscillatory motion. So it will go up to point B. It will be released from point A. Let me rub it. From the mean position I have taken to point A. Now if I released it, so it will move to point B. Again it will come back to point A. Then again it will come back to point B, and it will be continue motion. It will be continue in that motion. That is to and fro motion. Okay, this is basically to and fro motion. Alright, it will come. If I drop it from A, it will come to the new position B. Then it will go up to point B. It will come to new position O. It will go up to point B. Again it will come to O. It will go to A. Then again it will come to O. It will go to B. So to and fro motion will continue. Alright, this is to and fro motion. Okay, it will continue to be in the same way. So this is the back and forth motion of the bob via mean position. So it is always passing through mean position. So we say that it passes via mean position. Alright, this is called periodic motion or oscillatory motion of the bob. This is called oscillation of bob, basically. Not bob, it is bob. Oscillation of bob or pendulum. Alright, oscillation of bob or pendulum. Okay, so this was oscillation of bob and pendulum. Now this is an example of oscillation or periodic motion. So it must have some time period. Okay, it must have some time period. So the time taken to complete one oscillation is termed as the time period of the pendulum. Okay, now first of all let's define amplitude. First of all, what is amplitude? So amplitude basically is the distance of mean position to the extreme position, either this one or this one. This is amplitude. This is amplitude. This is amplitude. Okay, the displacement of the bob from the mean position to the extreme point. The distance between the extreme position and the mean position of the bob is called amplitude. Now, if I kept this left from this point, it came to point B, then again it came to point A. This is one cycle. Okay, this is one cycle. It moves from A to B, then B to A. This is one cycle. Time taken to complete this cycle is called time period. So time to complete this cycle is called time period, that is capital T. Alright, that is time period of this motion. So amplitude I have defined, time period I have defined. Okay, is there any doubt in this definition? Amplitude and time period, is it clear to every one of you? Is it clear to every one of you? Is it clear to every one of you? Answer to this question, is it clear to every one of you? Time taken to reach from A to B, then B to A, that is one cycle, right? It should reach to its position back. So A to B, then B to A. Okay? So is it clear to every one of you? Kindly respond quickly in the chat box. Okay. So to maximum of the people it is clear, I guess. Okay. So time taken from A to B and then B to A, that is called one cycle, and that time is called time period. Okay, from A to B, then B to A. So at this position it is at its position once again, right? That is at position A. It starts from A, goes to B, then comes back to A. That is one cycle, right? In case of Earth and Sun, what was the case? If the Earth starts in position after 365 days, it comes to position at this position only, right? Let's say it starts from O. So it comes back to O after 365 days. So that is why 65 days that period. Okay, that is why this is the time period, time taken to cover from this point to this point. And what is amplitude? Amplitude is, let's say I displace it to this point. Okay, this point. So this is called amplitude. This distance. This distance is called amplitude. This distance is called amplitude between the 2 points A and O. That is amplitude. Okay. Now let's talk about the formulas now. Time period I have defined. Time period is the time taken to complete one cycle. So time period is directly proportional to under root of length. Length I have told you, this is the length, point where it is fixed to the center. This is the length of the pendulum. So time period depends on the length. So time period is directly proportional to under root of length. Okay. Let's say if I have twice the length, if I make length as 2L, so time period will become under root 2 times of the initial time period. T dash will become 1. So it will increase, but it will not increase linearly. Okay, it will increase with under root power. Okay, and similarly, it is inversely proportional to the under root of gravity. It is proportional to 1 by under root g. Okay, and T is proportional to under root L, that is under root of length, and inversely proportional to under root of g. Alright, so can I say that T is proportional to under root L upon g? Can I say this? This you have to remember, okay? Don't get into history, geography of this formula, just remember it. You will get to know about this formula in class 11th and 12th. Is it clear to every one of you? Is it clear to every one of you? I am telling you, don't get into details of the history, civic, geography of this formula. This year will prove in the higher classes. Okay, just for your knowledge, I am telling you the formula right now. Don't type so much. I have asked you. That's why I'm not switching on the chat every time. You start playing with the chat box. I don't know what is the reason behind that. Start playing with the chat box. I don't know why. I asked you only one time. It is clear to you or not? I don't know what is wrong with every one of you. You are typing so much in the chat box. So T is proportional to L upon G. So this is the formula. T is proportional to length. Length is the length of the pendulum. Okay, the length, the distance between the point where it is fixed to the center of the pendulum, and G is the gravity. So it is proportional to under root L and inversely proportional to under root G. Now it is found to be time period is equal to 2 pi under root L upon G. This is the formula for time period. This you will derive in the higher classes. I guess in class 11th you will derive it. This is the formula for time period, or pendulum, or for bob. Now let's talk about this question. If the pendulum, when displaced from mean position, undergoes 40 oscillations in 20 seconds. So what is time period? So it is going 40 oscillation or 40 cycle in 20 seconds. Whatever one cycle it will go in 1 by 2 seconds. This is the time period, half second is the time period. Then what is the length of the pendulum? So length, you know that time period is equal to 2 pi under root L upon G. G you know as 10. So 1 by 2 is equal to 2 pi under root L divided by under root 10. Okay, so you can find out L from here. Okay, can you find out L from this formula? Every one of you can respond in chat box. You can find the length from this formula. See, it is half. Okay, what is time period? Time period is time for one cycle. Time to complete one cycle is called time period. Now 40 cycle, it completes it in 20 seconds. So one cycle it will complete in 20 upon 40 seconds. So it is equal to 1 by 2 seconds. This is the time period. This is the time period. Alright? This is clear to every one of you? Why it is half? Time period is half. Alright? Okay. Now, if you put in the formula which I have told you, that is 2 pi under root L upon G, you can easily get the length. You know what is the value of pi, what is the value of under root 10, what is the value of 2, 1 by 2, so you will get the formula. So you will get under root L is equal to something, so L is equal to, you will get from this formula. Alright? This was the formula for length. Now, what can be done in order to maintain the value of the time period of the given pendulum on taking it to another planet where acceleration of the gravity is 1/4 as compared to Earth. So G I'll make. So I have to find out now that what. So let's say length and gravity is for Earth, and T is the time period. So T is equal to 2 pi under L upon G. Now for other planet, let's say time period is equal to T dash, L dash and G dash. So G dash is equal to G by 4 and T dash is equal to T, because time period should be kept same and G is 1/4 of the gravity on Earth. So can I say T dash is equal to 2 by under root L dash upon G dash. So T dash is equal to T, which is equal to 2 pi under root L upon G, which is equal to 2 pi. From this formula what I will write? Under root L dash upon G by 4. So from this you can say that L dash is equal to 4L. L dash is equal to 4 times length if you want to keep the time period same. This is the answer. So L dash is equal to L upon 4. I'm sorry. L dash should be equal to L upon 4. L dash should be equal to L upon 4. You can find out from this formula. Okay? You can find it from this formula. Is it clear to every one of you? Is it clear to every one of you? It's very easy, right? It is very easy. Just keep the values and you will get the answer. Okay? Alright, so I will explain it once again. So time period I have to keep same, okay? So I will create time only. So time period for Earth is equal to 2 pi under root L upon G. This is the time period on Earth, which is equal to time period on other planets. So it is equal to 2 pi under root L dash upon G dash. Now G dash, you know, it will be equal to G by 4. Okay, G dash equal to G by 4. So you can cancel out 2 pi and 2 pi. You will get under root L upon G is equal to under root L dash upon G by 4. So from here you can write L upon G is equal to 4 L dash upon G. You cancel G, you can get L dash is equal to L upon 4. Okay, now is it clear to every one of you? Now it's clear to every one of you? It is simple mathematics, right? I've just done the cross multiplication. What is in the last part? I've just taken out the under root. I've taken square both of the sides. Okay, and it becomes L upon G is equal to, I'll take 4 above, so it will become 4 L dash upon G. It will be cancelled out, so L dash is equal to L upon 4. That's it. It's very easy, right? It's clear to every one of you? Can you solve it yourself? Have a pen and paper in your hand. Okay. Let's move ahead then. Let's talk about reference point. So what is reference point? Reference point is basically the point. The reference point is a fixed point from where all the measurements are made. Okay. So as we travel, we see some of distance and direction. Okay. And that is basically position from where the distance of the place is that kilometer. Okay. So this is the board for New Delhi. So the board where it is fixed, from that point, that point is reference point, and from that point New Delhi is 500 km. Similarly, it is given that Bombay is 800 km from that point, so this is a reference point, and from this point it is 800 km ahead in this direction. Alright, so reference point basically is very important if you want to write the distance with respect to any point. Similarly, in case of race, every race there should be some reference point, because just to remove the biasing, okay, just to remove the partiality among the sports person, they should start from a common reference point and they should cover an equal interval of equal distance of distance. Okay, so reference point is basically used for starting is used as starting point. From this point the distance is this much. Okay, that is why reference point is very important. It is very important for normalizing the distance and for writing the distance. Okay, so reference point, this, let's say it is at this point O. So if O is the reference point, then it is at distance 15 from O. So distance is very important with respect to reference point. That point C is at 15 kilometer of O, or B is at 35 kilometer of O. So O is taken as reference point. Now from C to B, it is 20 kilometer. That is 35 minus 15. So if C is taken as reference point, so from C, B is at 20 kilometer. So you can take any reference point. Okay, but you have to check it. Okay, so what is the distance of the point from this point? That is reference point. Okay, reference point is basically is the point from where the distance is measured, which is taken as 0. Reference point is always taken as 0. Okay, accordingly we will measure the distance. Is it clear to every one of you? Reference point, it's very easy, right? It's very easy, right? All right. So let's then move ahead and let's talk about this now. Direction in reference point. Let's talk about direction. So direction is also very important. Okay, distance is important, direction is also important if you talk about reference point. All right, let's say I have written my friend, let's say not my friend, Akhil lives 5 kilometers away from my home. If I say this statement, my friend is Akhil, he lives 5 kilometers away from my home, will it be a correct statement? You will be able to find his home? Will you be able to find his home or not? Right? What else you require for this? What else you require? Direction you require, right? Very good. Excellent answer. Thank you so much for your response. Yes. So this is my home. So direction required. Either it will be in this direction or in this direction. Okay, 5 kilometers. If you talk about from the sky, if you will see, you can move in a circle. Okay, it can be at any point. It can be at any point on this circle of 4 kilometers, 5 kilometers. Okay, so it will be, you have to move 2 pi into r. That is 10 pi kilometers you have to move. That is equal to 31.4 kilometers. To find his home, you need to move 31.4 kilometers in a circle. Okay, then only you will be able to find the home of Akhil. So that we require direction. If I say, let's say this is north, south, this is west, and this is east. If I say Akhil's house is in east of my house at 4 kilometers, so we directly move 4 kilometers in this direction. If I say in north, you move in this direction. So direction is very important. That is why on signboards direction is given. Okay. So direction is very important. Okay. Is it clear to every one of you? Is it clear to every one of you? Why direction is important? All right. Okay. So Suniket, amplitude is not clear to you. I have explained in the previous slide. You can go through my recording. It will be available to every one of you. Okay. So go through my recording and understand what is amplitude. I mean explained this twice or thrice. Okay. So let's talk about physical quantities now. So physical quantities can be written based on the quantity. It can be differentiated as vector or scalar. So scalar quantity are the quantities that have only magnitude, let's say density or distance. So it only have magnitude. Scalar quantity only have magnitude. So speed is also an example. Speed does not have any direction, right? If I say I am moving 10 km per hour, that is, this is the speed. It does not have direction. On the other hand, vector have magnitude as well as direction. So displacement is one example. Okay, and force is an example. You apply force on a body. Velocity is an example. Acceleration is an example. So speed along with direction is called velocity. When speed plus direction is provided, then it is called velocity. Alright, so velocity have two parts, magnitude and direction. Vector have two parts, magnitude and direction. Okay, is it clear to every one of you? Is it clear to every one of you? Alright, these are basically types of physical quantities. Okay, so scalar quantity are always positive. Vector quantities can be positive, 0 or negative, because it has direction also. Direction you can write as negative. Okay, so distance, speed, etc. are scalar quantity. Alright, now what is difference between distance and displacement? Okay, so if Rahul is moving from his house to his school, he covers up this path. Okay, he covers up this path. So distance basically is the total path length. Okay, distance is the total path length that is covered by the body. So when a body moves, it covers the distance. Okay, it covers the distance, it covers up the path length. And the straight line joining the initial and final position is called displacement. This is the initial position that is at home, this is school. So straight line joining the school and home, this is called displacement. The shortest distance between 2 points, that is the straight line. This is displacement, and the path length which it has covered, this is the path length which he has covered, and this is called distance. That is the path length covered by the body. Okay, and displacement have direction because it is a straight line, so it have direction also. Direction plus magnitude, because you can write this direction, either it is north, south. So displacement is always in a straight line. Okay, so you can write the direction north, south, east, west, positive, negative. You can write it accordingly. But distance, you can see the direction is changing. This direction again it is changing, again it is changing. So it is in multiple directions. So you cannot write one direction. So distance does not have direction. It only have magnitude. That is why we say, and displacement can be 0, positive and negative. Distance will always be positive because it does not have direction. If the object goes forward and it comes back to its home, okay, if he goes and again comes back, then displacement is equal to 0 because initial and final position are at same point. But distance is equal to 2 times distance between school to home. So distance traveled. So forward motion it will cover school to home, then home to school. So same distance, that is 2s. Okay. This was about displacement and distance. So displacement is basically a vector term, while distance is a scalar quantity. Okay. Is it clear to every one of you? Distance and displacement. Is it clear to every one of you? Distance and displacement. Okay. Okay, then let's move ahead and let's talk about difference between distance and displacement. So these differences I have told you. Okay. So go through this table. This is not that difficult. Okay. It is path length. It is straight line joining between initial and final position. That I have discussed. Distance is scalar quantity and displacement is vector. This I have discussed. This I have discussed. Distance is always positive. It can be 0. When the object does not move, it can be 0. But displacement can be positive, negative and 0 as well, because it have direction. We can take one direction is positive, another one is negative. Now distance can be added algebraically to find total distance covered, but displacement needs vector addition because it is a vector. So if there is distance covered 1 meter, then 2 meter, then 3 meter, it is directly added as 6 meter. Okay, but in vector you have to mention direction also. Okay, you have to mention direction also. I'll give you a question as homework. You will get to understand much more detail. Now whenever there is linear motion, there is distance traveled, but in case of displacement, it can happen without displacement also. For example, if a body moves forward and again it comes backward, so it moves forward and come backward. So displacement is 0 in this case. Displacement is 0, but distance traveled is equal to 2 times, let's say distance is s, 2 times s. So displacement can be 0, but distance will always be there when there is motion. Okay? Is it clear to every one of you? Is it clear to every one of you? Okay. See, velocity can have direction because velocity depends on displacement. Velocity definition is change in displacement with respect to time. Okay, so displacement have direction, so velocity will also have direction. Okay. Now this is the question. This is the question for homework. Do this question, I will provide you the hint. So the car starts moving from a point, it moves 50 meters towards north. So it moves 50 towards north. Then it moves 40 towards east. So 40 moves towards east. And then 20 south. It has moved this direction, then this and this. So what is the distance traveled and what is displacement? So this is distance, okay, the yellow color. And displacement is basically this green color. So this is displacement and this is distance. Okay. So this is the hint to solve this question. Alright. This was all about this lecture. So is it clear to every one of you how to solve this question? This is the straight line joining the 2 points, right? So you can solve. Alright. If you any one of you have any doubt, post your doubt and ask and answer forum. Sandeep, kindly stop posting these smileys. Okay. Don't post these smileys on the chat box. Okay. Alright, so if you have any doubt, I would recommend to ask it on Ask and Answer forum. Our expert team will be able to answer your question in much more details in a much better way. Alright. So this was all this lecture. Alright. I hope I have cleared each and every one of your doubt. I hope you have understood each and every concept. I would recommend you to go through my recording once again and go through each and every concept and solve more and more questions based on these topics. Alright. Meet you in the next lecture with some more new concepts. Okay. Thank you so much for listening to me and for such a nice response. Thank you so much. Have a good day and bye.